Hello everybody, my name is Cam Ruffle-Deignan, and in this video I will be talking about the in-depth offline analysis module available through SoundCheck called SoundMap. From a high level, SoundMap is a time frequency analysis tool that is used separately from sequences in SoundCheck and is accessed under the Offline tab. While SoundMap requires a module to perform analysis on your own time-based files, anybody is free to explore the included demo data well in demo mode of SoundCheck. So, since SoundMap is an offline program, I can find it under the Offline tab here. Down at the bottom, we click on SoundMap. So now we are presented with the initial window of the program. In this dropdown over here, we can find waveforms that might be in the memory list. I don't have any at the moment. Or we can browse and find files from disk. To the right of the data area, we can see the analysis parameters section. In this dropdown, we'll look at the four analysis types available. The first is short time Fourier transform. This is the most common and simple method used for time frequency analysis. Next up is cumulative spectral decay, and this is specifically used for impulse response analysis. After that is the Wigner Ville analysis method, which is used for a detailed look at small segments of a waveform. This analysis provides the best resolution of the four and can offer up to one spectrum per sample resolution. Lastly is wavelet. So this algorithm is quite similar to the function. It's similar in function to the short time Fourier transform. However, it's based on the concept of constant percentage bandwidth calculations, so it can provide more accurate results for applications that involve music or speech. And for each of the algorithms I mentioned, there is a parameter section that will change with the selected algorithm. For more information on how to configure these parameters, please refer to the SoundMap section of the SoundCheck manual. Lastly, to access the demo data and go on to the next step in the analysis process, I'll click Browse, and in this SoundMap folder is where we get demo data in the form of these MAP files. And this MAP file is essentially a post-analysis version of SoundMap, as opposed to taking a waveform or wave file and then running the analysis on it. So when I click on one of these, we'll just be able to go in and look at the post-analysis state of SoundMap, and this is where you would also be using demo mode in. You would be checking out these MAP files, and you don't need to actually have the module for SoundMap. After the analysis has been performed, we are presented with this window. In this post-analysis window, there are three main graphs of interest and an information section. The first graph that we see in the top left corner is the power spectrum graph. It displays time, which is shown on the bottom axis here, as it's horizontal, and frequency on the vertical axis over here. The color scale it uses symbolizes energy, with red being the highest and blue being the lowest. On the right of the spectrum graph, we have the frequency display. This is transposed from the typical format from how we view frequency and level. And the reason that this is done is so that the frequency axis corresponds to the layout of the power spectrum graph. With this display, there are many different selections that we can make for looking at different portions of the spectra and the waveform. An example is global, which is an addition of all of the spectra, or something like instantaneous, which just displays the instantaneous spectrum for a different point in time. At the bottom, there is the time display, and this display offers similar visualization functionality to the frequency display, but for the time domain. Again, we have an overall view. This is just a regular waveform view, and then different dropdowns here. Last but not least, there is the 3D button, which allows you to visualize each of these unique views at once. So let's take a look at that. So the 3D view is essentially a combination of the displays that we saw in the previous scene. So what we have here are these three different planes that represent all of those views. I can click and I can rotate around to see this in unique configurations. I could even use these buttons on the right here to snap to a certain view. Notice the fixed axes that we have. So we have a combination of those three planes, and then I click this button at the bottom to go back to the regular 3D view. While I'm here, I can orient myself in a certain way, and I can click this Save Image button and actually capture this specific moment in this three-dimensional view. So that could be useful for comparison from one file to another. Perhaps if there's processing on one and then no processing on the other. We also have the option of changing the color and layout. So we can change the axes from log to linear, or change to a waterfall kind of view of the spectra, having a little bit more resolution and no intensity data. So to end this video, I'd like to show a very quick analysis of a time-based waveform. So I'm going to browse on the disk to the data folder of SoundCheck, grab this P50 male speech, click OK. So one thing I can do is I can actually window a specific syllable here that I would like to analyze, or really a word, quote unquote, in this case. So I'll pick this one right here. So all I have to do is just window onto it. So now that this is my selected waveform, I'm going to use the wavelet function, and I'll click Analyze. Here we have the displays that we talked about previously in the video. For this particular snippet, I can select something like instantaneous spectrum and see at a specific point, like perhaps right here where we can see a high energy section, what are some resonant frequencies for that section. I can go to the 3D view, take a look at that in all of these different domains. In conclusion, I hope that this video got you excited about some of the prospects of offline time frequency analysis with SoundCheck. I encourage you to check if your license for SoundCheck has SoundMap and try utilizing it in your workflow if you have some extra time when working from home. Perhaps there are some archives of waveforms you have access to that you can take a second look at from a slightly different perspective. Who knows what type of insights you might have. If you do not have SoundMap, then you can always demo the program by putting SoundCheck into demo mode and checking out some of the offline .map files included as demo data. Lastly, if you're interested in acquiring the module for SoundMap, don't hesitate to reach out to our sales team at sales@listeninc.com. As always, thank you for watching and have a good day.